Test, test. All right. So, wow. Thank you, everyone, for coming. It's a lot of people. Hopefully the food is delicious. So a few weeks ago, I was talking to Fiona, and I was telling her we need to mix a good nerdy product talk. I've been seeing a lot of good design and engineering talks. So she introduced me to Matt over here, Matt Story, who has just created a company called Director.me. This thing's a little weird. Can you hear me okay? Okay. And also was the CTO at Handshake. So the thing I really like about is he kind of has this cross-disciplinary perspective, you know, where product isn't just a role, the whole team has to worry about that sort of thing, and he takes that sort of perspective. So I'm excited to hear about it, and afterwards we'll have some Q&A. So, Matt.
So I think we're good. Yeah, there we go. And formerly CTO at a company called Handshake, where I work with Fiona. And that in the past, and kind of the basis for my new company, and that is about how we get to predictability in delivering products. So who am I? This is a little bit about my background. I started programming when I was a kid. I founded a consultancy when I was in college. That was super fun. That was what we did back then. I graduated college in '06, went on to be an engineer for a bunch of time, was a good engineer, got promoted to being a manager, and then most recently founded my own company. I was looking for a cool picture to put up of myself, but I don't really have any that aren't bikes. This is my alter ego. I do bikes on Instagram, so you can look that up later. I don't have any of me giving talks or anything cool like that. But so if you look at the timeline of my career, I started programming, I founded this company, I went to school for philosophy, not programming, but then got a job in programming, and over this whole sort of early part of my career, I was learning, I was building things, I was contributing to some pretty big open source projects like FreeBSD and the Bash shell and Django. And then I got promoted to being a manager right around 2010, and I started missing a lot of deadlines, and we started missing a lot of goals. And part of why I got promoted was that the team I was on was already missing deadlines and missing goals. And so, I was part of advocating for making some changes, and when you do that, you get promoted. And so I was promoted, and then that trend continued for years. This was really a kind of a defining turning point for me. I think transparency and vulnerability are very important to me, so I wanted to share with you probably the worst professional moment of my career. So I got upwards feedback for the first time ever. And an employee of mine said, nothing is more demotivating and demoralizing than setting goals and consistently failing to hit them. So we had really bought into this OKR process. We were like religiously setting OKRs every quarter. We were doing that at the company level, the team level, all the way down to the individual level. And when the company has unattainable goals, you set unattainable team goals to try to roll up. And then you set unattainable individual goals. And you do this like 2-3 quarters in a row with a team that actually really wants to do the right thing. And people just it's just not fun. It's terrible. And it becomes this vicious cycle. So I changed that. I changed a bunch of stuff, and we started hitting our goals. End of the story, right? The reason you should actually listen to me is not because I was a good programmer or because I am no longer a bad manager. The reason that you should listen to me today is because I used to be a bad manager. And I think what I'm going to tell you about a little bit today is how I dug myself out of this hole of being a very bad manager and got to a point of being not such a bad manager, mostly using math and a lot of psychology. So, because I studied philosophy in school, I tend to go back to sort of like a priori truths. So like, what are the base truths, the things that we know to be true fundamentally? And so for me, before we even get to the question of like whether or not we care about when we deliver products, we need to understand first, why did we even build this product and engineering team in the first place? So this is like the most common answer you ever hear. Product and engineering build stuff, right? I'm a programmer, I build things. So if you believe that your product and engineering team is built to build stuff, you're going to have certain biases in the organization about what value that team is providing to the company, right? So the organization believes that it knows how to solve a problem, right? We believe we know what needs to be built. We just need to hire a team of people that's going to build that thing. That's going to lead you to hire people who have a bias towards action, right? People who get shit done. Then your engineering goals are going to likely be around effort, because you're going to say, as long as the team does their job and works really hard, the results will be there because we know what the results should be. And then your product goals are likely to develop delivery. So you're going to have roadmap goals. Sprint attainment, roadmap goals, milestones. They're all sort of flavors of the same thing. And that all flows down from just believing that your engineering and product teams exist to build stuff. Who can tell me what this is? Does anyone know? It's an overpass. This is the Cross Bronx Expressway. This is a cautionary tale in the limitations of getting shit done or building anything just because something needs to be built, right? There's a lot of examples out there. I've used like bridge to nowhere, road to nowhere, all these things. This one I think is actually much closer to reality in terms of what it's like to be in product and engineering, because this thing works ostensibly, right? Like traffic moves across the Bronx. You can get from New Jersey to Long Island in a mostly fairly short period of time. And so it does the job it was supposed to do. It moves traffic. But the way this got done was one man, Robert Moses, just said, we're going to slash a highway across the Bronx, and he destroyed a bunch of neighborhoods, and he created something that has caused a tremendous amount of bad traffic for the city. And basically every city planner since has said this is terrible, because the marginal utility, right, so the value of something that would have been better at relatively lower cost would have been so much higher if we had just taken a step back and thought about what we were doing, right? And so he got shit done, but it may not have been the best thing. So, pros of getting shit done. You have to build stuff. A lot of teams can't do that, right? So like, if you can't get over the hump of building stuff, you might just need to stop thinking about anything else and just build something. That is important. But it promotes a really binary way of thinking about goals. Like the existence of the thing is the only thing you care about, not whether it's good. There's no concept of marginal utilities. There's no concept of better and better at what cost. Value tends to be a linear curve or even sometimes an exponential curve. And it leads to the sense that like, well, we built it and now it's done, right? We don't have to maintain it, we don't have to iterate on it, we don't have to measure it. The existence of the thing is enough, right? So we can do better. We can improve this definition. So the next thing I would say, the next iteration is the product and engineering's job is to build stuff that's valuable, right? To build valuable stuff. The addition of this one word has a pretty profound effect, like that flows all the way through the organization, right? Rather than believing that you know it needs to be built, all you need to know is what the problem is, right? So the organization understands what the problem is. You'll hire team members who have a bias towards understanding rather than a bias towards action. They want to get the problem rather than just go out and build something. Your engineering goals will shift to measuring delivery, which is what your product team was measuring before. So are we building the things that the product team believes that we should be building to help our customers? And your product goals are more likely to focus on value creation rather than just pure delivery, right? So like, is the thing that we shipped actually adding value for our customers? You can measure this in a bunch of ways: adoption, satisfaction, unit profitability, enterprise value creation, depending on the type of business. But even this is a little not quite there. So one of my favorite CTO mentors once told me this. He said, my best programmer made me $3 million last year without writing a single line of code. Because product and engineering really create value by solving problems. And that might be super generic, but it does get you past the last hurdle here, which is there is no real relationship between effort and value, right? And that's a key thing to understand if you're in product or engineering, is if I hire you as a programmer or as a product manager, I'm not paying you to come in and work 12, 15 hours a day or to write code. I'm paying you to solve a problem. And if you can solve that problem in 0 hours with 0 lines of code versus someone next to you solving it in 12 hours, with thousands of lines of code, the programmer who's solving it in 0 lines of code is doing a much, much better job, and I will take that programmer 10 times out of 10 over the other one. So we exist to create value by solving problems. So this leads to a pretty hard problem. It was really easy to measure us when we were talking about building stuff. Did you build the thing? Great. Was the thing done on time? Great. Simple. So you need to think about your product and engineering teams as an investment, which is actually the way that executives and investors look at product and engineering teams. It's why, in product businesses at least, this tends to be in the R&D budget and not in the cost of goods sold budget, is because you are actually making an investment in your future. So a project is a single investment. You should look at it like a stock. You need to define the ROI of the project. So what value does this need to create? Are we looking for this to create 2, 3x our investment in terms of revenue growth or EV value creation? What's the timeline for demonstrating that? Do we expect this to pay us back in 6 months, a year, 3 years? What are the leading indicators, especially if that's very long? So how are we going to know it's working in like 2 months, 3 months, as opposed to 6 months, 1 year? What risks are we taking and what risks are we not taking? So there's always risk, right? Because it's an investment. Risk is where you make your money, right? You can't make money if there's no risk unless you have an arbitrage opportunity. And so we need to be really deliberate about where we take risk. So are you going to take risk in your schedule, meaning you not know how long it's going to take, and therefore that's the time risk and you might need more capital? Or do you know exactly how long it's going to take, but you don't know how much value it's going to create? That's speculative, so you're prospecting, right? These are different kinds of risk you can take on. And then how much risk are we willing to take? Is this like a mutual fund investment or is this like a VC investment? Are we looking for a 5% rate of return or are we looking for a 150% rate of return? We were talking earlier about roadmaps and how it's not the best way to measure it, but your roadmap or your collection of your projects is like an investment portfolio. When you roll all of these projects up, there should be an overall return on investment across all those projects, right? So if every investment is going to return 4x, but half of them are going to fail to do that, you might have a target around like 10% ROI. And so you need to understand how many of your projects need to succeed for you to hit that target. Projects do fail, something we need to acknowledge as teams. Not every project is going to succeed. How do we mitigate the unintended risks? So are there process improvements or tooling improvements or business continuity improvements we can put in place? And then what's our rate of return? So how long is it going to take? And then how long is it going to pay back over, right? So like every quarter we need to generate this much money to keep funding the business, or every 6 months or every year. So none of that changes the fact that you're still going to get asked this question. When is it going to be done? And so my answer for 10 years was in 2 weeks. That was like literally probably 90% of the time that was my answer. Everyone does this. We'll get back to this later. So this question actually has a very important place because if you're making an investment in product and engineering, your primary investment is in paying the team that's doing the work. That's where the money is going. That's where the capital is going. And there are tremendous costs associated with doing something for too long or paying people to do something that's not going to return on investment. And so actually knowing how long something is going to take is a really important question to answer if you want to understand your costs, your risks, the marginal utility, all that stuff we talked about in terms of looking at product in a way that's more than just like getting shit done. So when someone asks, when is it going to be done, that's not really what they're asking. They might be asking a bunch of different things. They might be asking because there is an actual like real world schedule risk out there. So the client has some deadline. We don't say clients, right? The partner has some deadline. I apologize. There might be a question about scoping risk, right? So like, is the scope likely to expand or can we cut scope to make sure that the schedule gets done? So this is a big thing in Scrum is time boxing, right? Fitting the requirements to the schedule rather than vice versa. There might be a question about the implementation risk. So is there someone on this team who can get it done faster? If we put more people on this project, is the whole thing going to get done faster? Is there a tool that we can use to get it done faster? Or the one that programmers like the best, can we take on some technical debt and get this done faster? What it is always a sort of a conversation. And so the thing I would impress upon product managers and programmers when you get asked this question is resist the urge to get defensive and say, I don't know, man, you don't get what I do. It's hard. Say, recognize that this is the beginning of a conversation, ask a lot of follow-up questions to understand where that's coming from and what kind of, and recognize that you're having a conversation about managing risk rather than whether or not you're good enough to get it done on time or whether or not things are, like someone's probing into your day-to-day and micromanaging you. All right, so that's what this question typically means. And this, I interviewed at this company like 3 months ago, and the CEO I was talking to was just like, why can't you guys answer this question? It's a simple question. And he's right. It's a simple question. But simple and easy are not the same thing, right? When something's going to be done is a very simple concept. We should all be able to grasp that concept. But answering that question might not be so easy. And I'm going to walk you through some of the reasons why humans are not good at answering this very simple question. So, you ask an engineer for an estimate. When is this ticket going to be done? Where are my engineers at in the room? 2, 3. You've all been asked this question, yes? Okay, so in your head, this is what it looks like. It's like, okay, so there's a probability curve here. And basically in your head, what we know is happening is that there's some date that we're going to call the event horizon. And it can never take longer than that date. You're like, oh man, this could never take more than 6 months. And so this whole area of time is off limits. All right, so it's going to be less than 6 months. And then there's some constant in your head that you multiply by, and you get to the date that you say out of your mouth, right? So you say, this is definitely going to be done by February, all right, January 15th. We're going to call this constant E. So like the estimate that the engineer gives you is the event horizon minus today times an engineering constant. And if you're a junior programmer, your engineering constant is likely to be pretty low. And this is actually why you pay senior programmers more. Like most companies will pay senior programmers more because their constant is higher. And so they'll guess right most of the time. They'll guess right-er. Good managers know this is a bullshit. They multiply by some number in their head, and that number changes based on the programmer. So that magically they always get to the same number. And this is like actually why a lot of companies pay managers, is to listen to what programmers say, use their experience to come up with a number that is usually between 2 and 5, multiply by that number, and then tell upper management that the programmer said this, but I'm a great manager, so I multiplied by 5, and it's actually this. This isn't the issue. The issue is that we model time badly as people. We don't deal with time well. This was like my area of study in undergraduate philosophy, so bear with me a little bit if I nerd out. The first problem is that there's actually a fallacy in that graph. If you say, all right, I'm going to take my date that it can't be longer than 6 months, and I'm going to say, okay, but half the time it's going to be done. It's going to be done half that time, probably. So you then say 3 months. Your math is actually wrong. What you've done is you've slid time backwards, and you've just divided in the way that our brains work and said, okay, 50% of the maximum amount of time it could take. What you actually want to do is you want 50% of the area under the probability curve, which is way over here, because we all know from experience that your delivery schedules are stacked towards the back, right? So it's way more likely that you finish this project near that date in your head that you think is magically you're never going to go past than it is that you finish it at any other point, which is why the area under the curve here is so much bigger. And so actually 50% is here, not here, right? And these numbers are pretty extreme. So that's problem number one, is if you're a programmer or a product manager, recognize that when you're multiplying by some magical constant in your head, that constant is against the probabilities and not against the time, right? And so it's going to be really close to the end of, to the time you think it's not going to take longer than. There is a much bigger problem though, which is that the graph is not shaped like this at all. The actual graph is shaped like this. And we know this because I've run a lot of simulations of projects, and I've looked at a lot of projects, and I've got all the data from the projects, and when you graph the project delivery, this is the actual graph that you get. Can anyone tell me what this graph is? Like what type of graph this is? You have a guess? No? Anyone know? An S-curve? Yeah, so this is a cumulative distribution, is what this is called. So the probability that something happens, if you were to turn this on its side, you'd get a bell curve, right? And so like the likelihood that any given point in time kind of looks like that. This is actually a Cauchy distribution, which this is going to freak some of you out. Cauchy distributions have infinite variance, which means that this is never going to hit 100%, ever. It's going to actually go out to infinity, and we just chop it off. And that's how projects actually look. There's actually a chance in every project that you take on that it will never finish, right? And so if you look at the probabilities, this steep area of the chart is normal, right? This is about 5% of the time it's going to happen here, and about 85% of the time it's going to happen within a span of this is probably going to end up being like 2 to 6 weeks on a normal size project. It will be right in there. But 15% of the time, it's going to be way out here. And in statistics, we have a name for this. It's called a fat tail, which means that the tail just keeps going. That there is a lopsided amount of probability that something takes a really long period of time. And interestingly enough, Cauchy distributions are used by investors to analyze and model risk because they accurately reflect risks. And as we learned earlier, as a product team, we're really taking on risks intelligently and trying to manage those risks in order to produce a return on investment, right? And so the whole thing actually makes fine sense. There are very large consequences to the fact that the curve is shaped like this. Your 75% confidence and your 95% confidence states might be months apart, right? Like I've seen graphs at Handshake where our 95% confidence was 6 months out from where what we were saying to the business, right? And so you're going to look at that and you're going to freak out, but I think if we all reflect on all of our experience with delivering products, this is actually pretty close to reality, right? That things tend to go really wrong a lot more than they tend to go really right, right? And the reason for this is pretty simple. Schedules are outlier dominated. You could hit like 95% of your estimates, and if the last 5% were off by a factor of 10, which is what's going to happen, you're going to blow your schedule by like months of time. And this is why things like sprint attainment or story points are kind of immaterial, because you can hit every intermediate sprint except for one, and that one intermediate sprint might be 6 months worth of work. So, number one thing is we need to adjust our mental model from being this exponential curve where things get really likely until a point in time where it becomes impossible that it's wrong, to this fat tail model. And even once that's done, there are a lot of variables. So you have different staff. The staff have different experience. Vacations are huge. Holidays are huge. We're about to hit December where productivity is going to probably plummet. And there will be massive vacation schedules that will shift your schedule like 3 to 4 weeks if you don't factor them in. There is the completeness of understanding of the requirements, implementation, tooling that's been rolled out. And then, of course, there's the most flippant, it's the question that the answer that everyone hates to get from a programmer is, well, that depends on what your definition of done is, but that's like a real thing. So why does this even matter? This is hard. Well, it matters, number one, because the whole business needs to actually run, right? And we know things about our delivery, and we can adjust our mental model, and we can have an understanding of our risk. And so let's just talk about how we're going to do that. Let's talk about how to set yourself up for predictability. I think it's become very popular now for engineering managers in particular to push back usually on product managers and say, we can't estimate. We can't do any of this. This is crap. It's not important. And I think that's kind of lazy. Like, I think it's a cop-out. I think we can do it. I just think there are a few things we have to change. So number one is to change your mental model. We need to eliminate that event horizon line, right? That date in the sand that we won't pass. And so there's some really easy things that we can do to fix that. And they don't even involve math or drawing charts. Number one, if you're a product manager or an engineering lead or a programming manager, there's a lot of literature on this. Never give someone a date. That is how that event horizon exists in the first place, is because you told the programmer that. Will it be done by Christmas? The programmer has just put a line in the sand at Christmas that you will not cross, and any date they will give you is going to be before Christmas. Just ask them how long it's going to take, right? Just don't give a date to stand up against. As a programmer or a product manager, recognize that you have a default answer, like 2 weeks, and that answer really should be, I don't know. If 2 weeks comes out of my mouth now, I stop myself and I say, you know what, I don't know. 2 weeks, no, shit, wrong. I actually don't know. I need to think about it. Have a conversation when you're asked when it will be done. So recognize that is a conversation, not something that's looking for a factual answer. Talk about delivery range and confidence intervals. So the easiest thing you can do is to ask your programmers, when is it going to be done 50% of the time, 75% of the time, and 95% of the time. And that'll give you 3 data points, and then you can start to map out that curve in your head. And do not push the 95% number back. If anything, you want to push that number out, right? That's where you apply your multiplier. Remember that your distribution is far more likely to go off to the right side of the graph, way out in time, than it is to be done in the normal amount of time. So look at your past issue delivery curves, right? Before you even get into the math, just look at how long a project actually took you from start to finish. Just look at all your projects, all your initiatives, and say this one took 6 weeks and they said it was going to be small, this one took 5 months and they said it was going to be big, and just get a sense of what those historical dates are, so that when a programmer says it's going to be 4 weeks, you can go, every single time we've done this, it's been 6 months. Analyze your time to value on past projects. So understand what done means, really, right? Because shipping the thing doesn't matter. Driving value for your partner matters. And so you have to actually understand how long it took you, not just to deliver the first iteration, but to iterate all the way to value, because that's what you're actually getting paid to do. Push yourself to get an actual distribution, an actual spread of dates for these 50, 75%, and 95% dates. Don't say 2 weeks, 3 weeks, 4 weeks, right? It's probably going to be 2 weeks, 6 weeks, 5 months, right? Like, that's not a joke. Some of you probably, it's not a joke. It's real. It's unfortunate. And then don't change your model just because you don't like the results. It's like the most common thing. Well, this says our roadmap's not going to be what I wanted it to be this quarter. Well, that's just reality. Wouldn't you rather know reality now than at the end of the quarter when you've missed your goal and everyone's demotivated and sapped because they've been working super, super hard? So trust the results. Don't second guess the results. And don't push to make things more aggressive, especially when you're stacking project on top of project, because then the risk compounds, right? And so if you're taking the 50% estimate for every project to determine your quarterly roadmap, you're going to miss by like 75%. Does that make sense? Think less granularly. You know, you should be thinking at the initiative level. It's really tempting when you start missing deadlines or you start missing schedules to really get into everyone's business in a way that's really ineffective. You don't hit your roadmap, you don't hit a quarter, you don't hit, you know, delivering all the value you want to deliver by persecuting every single story that an engineer is estimating. You have to take a step back. Number one, look at all the way done, not dev done. Dev done is a term that should be killed. It is a useless concept. The devs are done when the value is delivered. That's your job as a programmer. And so never talk about dev done. Never talk about ideal days, developer hours, developer days, like this will take me 2 hours, 3 hours. Think about calendar days. That's how the world operates. That's how your partners operate. They don't care if it's going to be done in 35 man hours. They care if it's going to be done by next Tuesday, right? Because that's when their team is going to start marketing it. Always days, never hours. Hours are way too granular. You can lose a day like that just if you wake up and you're hungover and you show up to work an hour late and then you go to lunch and then you have a conversation with someone and then there's a code review. That's a day. You're done. Your 2 hour estimate is now completely gone. Your 5 2-hour estimates that was exactly 1 human day is definitely shot. And then your scope is going to expand. So even if you have all the epics figured out and you have like, okay, I know it's going to be 5 small epics and 2 large epics, what's that add up to? Recognize that that's probably not reality. And so go back and look at other projects that were like this project and call on those to figure out how much it's going to expand once you start. All this stuff is really easy stuff. And also stop hearing about estimates. This one's kind of weird in light of everything else that I've said. But we're not actually looking to be good at estimation. This is like the #1 question that I get asked that is the wrong question. Is, hey Matt, you talk a lot about predictability. How do I make my team better at estimating? And the answer is you don't unless you can make them computers. People are just bad at estimating. You need to factor that in. You need to understand that we can change our mental model. We can start talking about days instead of hours. We can start talking about actually done. We can look back at our past performance. And as humans, we're still going to say 2 weeks, right? So #1 is you don't need it. Just look at your data trust your data, trust what it tells you, and disregard what people say. 2, definitely don't spend more time estimating. It sucks. Has anyone here played planning poker? Do you guys play planning poker? Does everyone know what I'm talking about? Okay, so planning poker is when you all get in a room and someone says a story. And it's based on this idea of wisdom of crowds. This is actually big in the Cynefin world. But the idea is you say, okay, 1, 2, 3, flip, and then every programmer in the room flips their card. And it's like, you keep going until there's a consensus, right? Oh, this is a 3. And so then you have a discussion about, oh, you said it was a 5, you said it was a 1, and then you just keep going and going and going. And the whole thing is really silly, and programmers get super entrenched in it, and it goes on for hours, and it's a disaster. And it requires product managers to be really good at managing it, or scrum masters, or some amount of oversight. It's terrible. And it's useless, because it doesn't make estimates better, because your estimates are still going to be bad, right? So just do them fast. Like, gut is all we're looking for here. Swag it. Like, is it a small, medium, large? Go. Is it a 1, 3, 5? Go. Use your past performance. When this programmer said that was a 1 and it was a JavaScript project, like, what are the last 10 ones he did, and what did that look like, right? So use that to correct for the fact that the estimate is going to be bad. And always look at wall clock time, never dev done time, right? So like time they picked up a ticket to the time when the ticket was actually adding value to the customer, meaning all the bugs were solved, it was shipped, you iterated on all that stuff. Finally, don't talk about time when estimating. Ask small, medium, large, 1, 3, 5. Do not ask in days. Abstract that out, because programmers have weird conceptions of time. You just want a relatively correct estimate that's probably still not very correct. So I'm going to tease a little bit about what my startup does, because it's sort of based on all these concepts. There is actually an open source project that I authored at Handshake that is available to do this, which I would be happy to point anyone who's interested in that at. You don't need all of the stuff I'm about to show you to get better at thinking about predictability and value and delivering value as a product and engineering team. But it does help in certain ways. Number 1 is you can replace this mental model in your head with an actual statistical model. And then you have something concrete to talk about. So we can take information from Pivotal, from Jira. We can take that information from all the projects you've done in the past, and we can produce curves that look like this so that you don't have to actually go back and dig into the project management. You can actually just look at this curve, and you can say, okay, I know what the confidence distribution is, and that gives me an idea of the risks. When you do this, you get a more accurate model. You can tune your sample selection so you don't have to go through and pick it by hand and say, okay, so Matt's 1 versus Fiona's 3. You can track changes to forecast over time, right? So I can say, over the past 2, 3, 4 weeks, has this project pushed back 2, 3, 4 weeks, or is it actually still on schedule, which is very important. You can also look at the shape of it, right? So like how many larges, mediums, and smalls are there now versus where there was, last week, 2 weeks ago. And you can get alerts when things are starting to go right or wrong, right? Meaning someone's working on a small ticket, it's been in progress for 3 days, hey, there's an outlier happening here, right? So you have like sort of an outlier detection system, which is basically the main purpose of stand-up, right? Is for your manager and your peers to ask you every single day the exact same 3 questions, and hopefully someone is not hungover enough to catch the fact that you're struggling within a couple of days so that the entire schedule is not blown. And then we could take that and we can go one step further, and rather than just forecasting, we can actually start to set goals around it, which is what I would really sort of push you all to do. We can track and monitor our performance as well. And we can do that using sort of the data exhaust of our project management system, as opposed to you having to go in and track it. One thing we've done in the past at Handshake was say, I want you to beat your 50% mark every time. And if you do that, we can actually prove that you're getting faster. We can say we want you to get more predictable around the number of trips through QA, or we want you to improve this part of the cycle, right? Like so post-launch to value creation, or like your interaction with product management. It should be integrated in your existing workflow. This is the number 1 reason why these goals don't get set, is that they get set in tools that you don't use every day. And then you can get alerts before you go off track, so you can be proactive and not reactive. If you do start to make the shift towards going more data-driven, there's essentially one thing that I would caution you on, which is that data is just facts. It's not knowledge. And so the best you're going to get out of your data is an inspection of things that you should look at, right? Like it's going to be a list of, here's some things that are interesting. Here's some outlier things. Here's some things that are going well. Here's some things that are not going well. You should have a conversation about these things, not you're bad or you're good because of these things, right? And so that's really, as I think we start to move, whether it's through Director of Me or through some other piece of software, towards being more data-driven as we use all these different tools to inform how we work and predict how we're going to deliver and perform. It's very, very important to not sort of start to feel like we're in the panopticon and to start, just shifting conversations to be about sort of these facts and these predictability curves and things like that and what those mean rather than assuming that is actually just knowledge itself. I think that's all I have. How are we doing on time? Pretty good. Yeah, it was pretty good on time, right? About half an hour? Questions? Oh. That's good. Sweet.
Actually, I have one myself.
Yeah, that's a good question. So the question is, what is your take on velocity? So for starters, how familiar is everyone with this concept of velocities? Generally understood. So there are two schools of thought on velocity. One is that we should measure effort velocity, and one is that we should measure value velocity. I don't have a huge problem with value velocity. I think that effort velocity is completely meaningless. So effort velocity would be an attempt. It's actually, so velocity, let's just start with the name is a really poor choice. It's not actually speed. The goal of velocity is to get your team to do the number of people times the number of hours in the week or the number of days in the week or whatever your points convert to every 2 weeks. And so the goal of velocity is actually consistency and cadence, not raw speed. And I think the challenge with it, and I've given a couple talks that had a different slide in it, is that what it trains teams to do is to slow down over time. And so if anyone's worked in a place where Scrum has just been implemented for the first time, the first 3 Scrums are the most soul-crushing experience of your life. You miss the first one horribly, you try really hard the second one, you miss it probably even worse. The third one you try even harder, you sort of limp into the line, you maybe get 90% of the way to your goal, everyone's burnt out, you go into this sort of valley of despair, and then everyone keeps padding their estimates until you get to the point where you hit your sprints. And that, we then call that yay predictability, right? Like we've achieved 40 points a sprint. And I think that's fine at that point. But if you talk to people who have been in Scrum systems that have been implemented for years and years and years, like Shutterstock, not to call out a company, but to call out a company. If you talk to any programmer who's worked there for years and years and years, they just are so slow. And they just feel so slow. Because there's no expectation that anything gets done, because they can say that's an 8. And what's a product manager going to say? No? Well, it's an 8. And so beyond the fact that I think it actually slows teams down, I think it just focuses on, it puts the emphasis on the effort. And again, programmers don't get paid for effort. And I think this is a big problem in the industry, especially in startups, where there is this concept of the hero programmer who's slamming nights and weekends and probably drinking lots of Red Bull and vaping a tremendous amount and just working 20 hours a day. And I just don't want that person on my team. I don't think they do good work. Generally, I was that person. If you swap cigarettes out for vape, it wasn't good for me. I didn't do good work. The most effective programmers I've ever employed have worked very few hours compared to other people, and they just think critically about problems and solve them and are consistent and don't burn out. I don't know if that answers your question or not, but yeah. Sorry to any vapors.
I was wondering, how do you pair this mental model that you've presented with like a target deadline if you're working with a partner, and how do you mitigate the like scope and unknowns within this mental model you present?
Yeah, that's a great question. So I think what's really cool about this is, so if you have a tight deadline, or if you have an actual deadline and there's a real business case to be done by a certain date, there's like one prerequisite that I would call out here, which is that you have to have flexibility in your scope. So if you have a tight deadline, and that's the most important thing, then there has to be an upfront conversation with the partner to say, okay, but we're going to be flexible about the feature set that we have by that date. And then once that's done, every week or every day, you can look at your forecasts and you can see where that deadline falls on your confidence curve. And then you can really start to make very informed decisions about where you cut scope and how much scope you need to cut, as opposed to just swagging it, right? And you can do it from very far out. Because what tends to happen with deadlines is programmers in their head go, 6 weeks is larger than the 2-week number that everything is in my head, so we don't have to cut scope. And then you get inside of that 2-week number, or whatever number is in their head in terms of what they can achieve an infinite amount during. And then it's like, oh shit, we have to cut like 75% of the project, and it becomes like this panic, and you end up working a lot of hours, and you end up really micromanaging the team, and you have to be on everyone, and everyone has to make every minute count. And if we could just start having those conversations 8 weeks out, 10 weeks out, then we could be much more intelligent and surgical about when we start pushing harder, what we cut, having conversations with the partner 6, 8, 10 weeks out to say, hey, you know, we need to consider cutting this one thing, which makes you look really professional, as opposed to coming to the finish line with a team that's burnt out and looking kind of panicked and saying, okay, so we're going to get 80% of it done 2 weeks late. So that's how we've used it in the past. And we've actually done, we used to do quarterly roadmaps at Handshake, which is not something I'm very fond of, but that's how we did our quarterly roadmaps, is we would take and we would forecast all the epics, and then we just stack them on top of each other and take a really high confidence estimate and flow it through and see how long it would take. And that produced tremendously better results than all sorts of other sort of like what Fiona would call capacity planning Tetris that we used to do before that, where we'd have like a spreadsheet and we'd try to make every little box kind of fit, and it was terrible. Does that answer your question?
Hi. So designers here usually sit in on planners to be able to give context to engineers and to managers, project managers, about like a particular flow or how something should work. Is there anything in your experience that designers can do in addition to just sitting into Planner to help with estimates?
Yeah. Well, to help with predictability, because estimates are going to be bad no matter what. So I think you can apply this whole process to design as well. It's something I wanted to do at Handshake and never had the time to do, mostly because my designers were always way ahead of my engineers, like constantly. It was awesome. We had great designers. I think the biggest thing to me here is that product engineering and design works together from inception all the way to delivery, right? And so the thing that really kills schedules is handoffs. So like in my stand-ups, one question that I always ask is, like, who do you depend on today, right? And let's make sure that they actually have time in their day for you. And so programming and design are both really flow-driven activities, as any creative activity is. And so if you're a programmer, the difference between getting the answer right now to a design question and 5 minutes later is like the difference between having a good day and a bad day. And the same is true for design with products, right? It's like getting the answer to a product clarification question right now when you're in flow versus 5 minutes later when you're on Facebook doing God knows what for the next 3 hours is massive, right? So I think it's important when you're in execution, if you're in design and you have programmers who are executing on your project, to carve out time to be interrupted. And that will help you achieve better flow, and the flow will help you achieve more predictable results. And I think the same is true for product managers when you're in the design phase, right? The product managers in general, I think, is a largely interrupt-driven job for most of the cycle. So being there to answer questions for programmers or designers at the moment it happens, like at arm's length, not 30 seconds later, and being receptive to that and open to that and saying, no, it's my job to help you, like we're on the same team, is the #1 thing by far.
Thank you.
I answered all the questions in my talk, I guess.
Regarding the previous question and your answer to it, I feel like I've encountered a number of occasions where, in the same way that our team can be unrealistic about time, a partner can be unrealistic about their like true capacity or willingness to cut scope. And so having those conversations, like regardless of whether the partner says yes, no, or maybe, they might mean no. So I'm wondering how like this system can fit in that context, like when the scope really is fairly inflexible.
Yeah. So I think that the issue there is one of trust, meaning, or they believe that that's just a good management technique. And that's not just partners. Like I've had bosses, you know, none that I will name by name, who believe that, you know, like everything has to be done and everything has to be done in this time frame. And I think what you can say is, you can say with the team that we have, based on our past performance at the current scope, the reality is this is how long it's going to take. We can change any of those variables. And I think if you empower the inflexible person to make the decision, that usually is enough, as long as you explain to them all of their variables. And then, like, they get obsessed. It's like, you know, being at like a mixer in a sound studio. It's just like, I can tweak this knob and it sounds like this, and I can tweak this knob, right? So like, you just have to lay out for them all the knobs because they're not an expert in project management, right? So you're gonna say, okay, so in the current configuration, this isn't gonna work. If I had more budget, I could hire different people or more people, and that knob would tweak it like this, right? That's a hard one because you have to hire them and ramp them. But if it's a 1-year project, that actually might be a way to really move the needle. You can also say, or I can pull in this other team and help, but that's going to require me to say no to this other client or this other partner. And so that's going to cost, that's a huge opportunity cost to me, and so you're going to have to pay me a lot more for that. So budget is a big thing. Or we can change the scope. And as you turn that dial, you can look at these numbers go in and out, right? And so you don't have to trust me, right? Like getting the trust question out of the equation is like, it's not just like I'm saying this and you're paying me for my expertise. You're paying me because I build great products. The facts are telling us that it's not going to be done, and we have to turn these dials together until they're right. And so yeah, it's really budget, scope, feature set, implementation. And if you just lay out all the options, the last one I usually put in front of people is implementation, because 9 times out of 10, someone will say yes, technical debt. Like almost always. If you put that on the table, of course, yeah. It's going to be shitty for us in 2 years, great. Whatever, we'll deal with it then. But yeah, if you give them all those dials to turn, I think they'll delight in turning them, and they'll feel super involved, and it will be new. And then the most important thing is it puts the responsibility for the decision on them. And they're the one who's reaping the value, and so they should really be the ones that are, you know, making the decisions about the risk, and then you're truly partnering with them on this conversation and not advising them. And I think that should work. Every once in a while, you get someone who's super intractable, and I would say the best thing to do in that scenario is to say, there are probably other people out there and other shops out there that will tell you they can get this done faster, and I invite you to try it. And then they'll go do it, and it'll fail, and they'll come back. Or at least that's been my experience. It's like, it's better to be honest and you know, build a relationship based on trust than to lie and have someone have a bad experience. Unless that's not how you guys do things, in which case I retract everything I just said.
What are your thoughts on acceptance criteria and the best ways to to produce that as a team? Because I know it can vary estimations, and you can go into rabbit holes with it, but it also can help with the quality.
Yeah, again, so I think so is everyone familiar with acceptance criteria as a concept? Cool. So the best way to do it is a H3 in Jira. That's how we always used to do it. We had a little list at Handshake for acceptance criteria. So I do believe in them, and I think they're important. I think it's important as a means of establishing what everyone in the room believed was done at a certain point in time. And I think that's useful, right? So like, even though plans are going to go horribly awry, it's useful to plan. It's the same way I feel about acceptance criteria. If you get to the end and you have satisfied the acceptance criteria, but it sucks, then you should revise the acceptance criteria. And as a programmer, you should be open to that. And as a product manager, you should be open to that, right? Because at the end of the day, we're trying to deliver value. We're not trying to tick the acceptance criteria boxes. But insofar as it is a useful way for you to keep track of what you're doing as a programmer, I think it's great. Does that make sense?
If like as an organization, like someone's like has fallen into a lot of these traps, has built up some of these bad habits, like are there things that you've seen in your career that can like get them to be introspective and like try and do things a different way?
So which traps in particular?
Just like for instance, like we as an agency, we start off with an estimate that we and the partner agree to, and that'll always be an external factor, which I think more often than not, like scope isn't really a variable. So I think
scope or schedule.
Both. Sorry, both aren't really variable. So, like, saying that one of those needs to be variable, and like if most of the agreements we enter into like end up with both of those things not being variable, like obviously the change we need to make is to not enter into agreements like that. So,
well, maybe there's another variable, which is budget. So I worked for a consultancy, like a very early like multimedia digital interactive agency. We did like social networks for everything back in the aughts. It's a thing we say now, I guess. I did like a social network for butterball turkey recipes. It was like 5 wishbones and like, it was really bizarre. We did another one for like obituaries. It was a weird time on the internet. And so, like I said, at the beginning, you as an organization, where you choose to take on risk will define what you care about as a company. And so if you are unwilling to bend on scope or schedule, that's a way to do business, right? And there are going to be consequences to that, positive and negative. And that's the way that risk is. The consequences of that are sometimes you're going to go over budget, and you're going to probably eat it, or the client's going to eat it, and it's either going to be a difficult conversation or you're going to take it on the chin. Sometimes you're going to get way out ahead of it and you're going to crush it and you're going to produce a lot more value, and either way you're probably going to have really satisfied customers and your LTV is going to be super high, right? And so if you're willing to take a hit on the budget on one project because the lifetime value of that customer is really high, then that's a totally solvable problem. It's just a problem that's solvable with budget. I will also say, as much as I talk about like sustainability, and I think that's important, there are times when you have to do unsustainable things. And I know that's like a startup or technology cliche, but it's true. And so, if you have salaried employees that are a fixed cost, sometimes you don't have to sacrifice budget to get it done on deadline. And, that's why you have salaried employees, because not all the time you're going to be 100% allocated and they won't have to work so much. And then sometimes you're not going to have to pay them overtime, and that's great. And again, so that's really, I would just look at that as a budget risk that you're taking. If those two things are in fact inflexible. What I would say is, just taking a step back from that, I think there are some consultancies that have been successful in having sort of variable, like saying the scope of delivering this thing is pretty fixed and the schedule is pretty fixed, but the value, when the value might show up, is pretty flexible because we're actually doing something new here. And I think it's actually important when you're doing something legit new to recognize that the first trip to the plate might not do it. And so that's just an expectation management issue, but you can still agree on like scope and budget and all those things and then say, but you know, we'll put it out there and we'll see what happens and then we'll follow on. And then if you hit all those deadlines and you know you nail the project, then you'll have the follow-on effects of getting paid more for iterating. Does that make sense?
Yeah. Thank you.
You mentioned technical debt in a way that sounds like you don't necessarily believe that that's ever an acceptable variable to tune.
I don't think I said that.
So I'm wondering if you can speak more about why that's your perspective.
Jesus. I'm having a bit of a mid-programmer manager life crisis about technical debt, so that's probably why I've come off as confused and aggressive at the same time. So my big concern with technical debt, so let me just say that I have taken on a lot of technical debt in my life, like a lot, like irresponsible amounts in many cases. And my reputation actually in a lot of ways is being a guy who comes in and cleans up a lot of shit. Like that's actually what I've done at a couple companies now in a row, 2 or 3, whether it's team shit or technical shit or both, or process, right? And so I've seen some shit. Like at Tablet one time, we were restarting the servers every 45 minutes for 72 hours straight. Like I've seen some debt. The concern with technical debt is that it very rarely gets paid down. And so the concept of debt as an analogy is it's more like a bond that you take out that you issue that you never intend on paying back unless it's like super convenient. So I think what I'm bigger about right now is I think that you should compartmentalize your system in such a way that you can throw stuff away really easily. Because I think that the refactoring doesn't really happen. But I also think that you should really measure your technical debt in terms of its impact either to the team's productivity, right? So like if you want to make a case for technical debt, I'll tell you how to do it. One is your own productivity. You're very expensive. Programmers are like the most expensive thing a company spends money on, period. And so if you came to any reasonable manager and said, if I do this 4-hour project, I will recoup that 4 hours in the next month, everyone will say, yes, do it immediately, right? Because it's a permanent increase in your productivity. The problem with tech debt projects is they usually tend to be quite large, right? So like if you can make it bite-sized chunks and you can argue that the payback period, which is how you should talk about it, is really fast, then I guarantee you it will be prioritized. The other thing you can do is say that if there is an actual bad experience to the end user, you can quantify the cost of that to the value of the product, in which case you will also typically get a tech debt project like through, or you should. Yeah, it's like site speed, for instance. And its impact on conversion rates in certain key funnels. That would be like a good way to get a project done. As long as it's very discrete, those usually get done. The bigger stuff that doesn't get done is like, this system is a nightmare and I'm having trouble expressing why, and like there's some Halstead metrics that say it's really bad and I'd like to refactor it. It's going to take like 3 months and you know it'll be way better. Because everyone on the other side of that has had the experience where someone says that and then it's 9 months later and you're mired in this project and it's not done and you chuck it and everyone's pissed off. And so if you just make things really small, then you can just throw them away and you can rebuild them. And so like what I'm trying to do as I'm coding again now and writing horrible code, I'm sure, or at least what my future self will think is terrible, is I'm trying to make every subsystem something that I could rewrite in 2 weeks, max. And then if I get really pissed off about something, everything's 2 weeks, right? And so if I have a 6 month or less payback period, it's worth rewriting, and if I don't, it's not. And the decision becomes very binary. That probably didn't help because it's I think a really hairy topic, and right now I don't have investors pushing me to hit revenue numbers, and so I can be very optimistic and idealistic about it. Like once I have investors and board and revenue targets, I will tell you that I will take on probably a large amount of technical debt, and then there will be a really bad quality incident, and then we'll probably get written up in the tech press, or at least I hope we're successful enough to be like have a takedown piece written about us, and then we'll have a really reactive period about that, and I'll come back in 5 years and tell you the whole story. Yes. Yeah.
And then accrued technical debt is kind of like your last resort, and you make it on the team, not outside.
Yeah, so that is true. Where I probably was confusing everyone initially was that is oftentimes the first lever that gets pulled, and it should be the last. Like once you've exhausted the scope and budget and timeline conversation, then you should say, okay, so there's this thing I don't really want to do, but I could do it. Then you have that conversation at the end. That's totally fair.
What's the first step in pulling this data out of Pivotal Tracker?
Yeah, so you need to define the stages that are dev done and the stages that are done. And then you need to just do a query and pump it out to Excel. And so if you have 3 columns, one is the ticket ID, start date, finish date, that's enough to get you started. And do that on the initiative level and do it on the story level. The story points are helpful. I'll tell you what I found useful is the best predictor is going to be that engineer with the same estimate. The second best predictor will be that engineer recently, any estimate. And then the next best predictor is any engineer recently, regardless of the estimate. And then the next predictor after that is that engineer a long time ago, basically. And then the whole team a long time ago. And then eventually you get to like programmers at other companies, but you don't have that data. So those would be like the ways I would pick. So yeah, story points, start date, end date, programmer. Thanks.